You know the moment. You open your maps, and there it is. A tiny blue dot sitting exactly where you are. You walk, it moves. You turn, it follows. It feels obvious. Of course your phone knows where you are. But have you ever stopped and actually asked, how? How does a device in your pocket pinpoint your exact location anywhere on Earth? How does it work inside buildings, between skyscrapers, even when your GPS is turned off? Today we're finding out how your phone knows where you are. Let's start above you, far above you. About 20,000 kilometers in the sky, there are satellites, dozens of them. They are moving fast, thousands of kilometers per hour. And yet, they never lose track of you. Each one is constantly sending out a signal. Not a message like a text, something much simpler. Just two pieces of information, the time and its position. That's it. No maps, no directions, just time and where it is. So how does that help your phone? Here's the trick. Your phone doesn't measure distance, it measures time. When a satellite sends a signal, your phone receives it a tiny moment later. That delay is incredibly small, billionths of a second. But signals travel at the speed of light. So even that tiny delay tells your phone how far the signal traveled. Now your phone knows one thing, how far away it is from one satellite. But that's not enough, because that only tells you you're somewhere on a huge invisible sphere. So your phone keeps listening. A second satellite. Now 2 spheres. A third satellite. Now the overlap gets smaller. And when your phone connects to a 4th satellite, it finds the exact point where everything intersects. That point is you. Latitude, longitude, even your height above the ground. All calculated from time. But here's where things get strange. For this to work, time has to be perfect. If your phone is off by even a tiny fraction of a second, your location could be wrong by hundreds of meters. So how do satellites stay that accurate? They carry atomic clocks. Clocks so precise, they barely lose a second over millions of years. And even that isn't enough, because time itself is not constant. Satellites are moving fast. They're farther from Earth's gravity, which means time passes slightly differently for them. This comes from Einstein's theory of relativity. And if engineers didn't correct for it, your GPS would drift by kilometers every single day. So every time you check your location, you are relying on physics, space technology, and relativity just to find yourself on a map. But GPS isn't perfect. In cities, signals bounce off buildings. Indoors, they weaken. Underground, they disappear. So why doesn't your blue dot just vanish? Because your phone has backup systems. Your phone is always connected to cell towers. Each tower knows where it is, and based on signal strength, it can estimate how far away you are. One tower isn't enough, but multiple towers create another estimate of your location. Less precise than GPS, but reliable. Now here's the part most people never notice. Your phone is constantly scanning for Wi-Fi networks, even when you're not connected. Quietly, in the background. And those networks have been mapped. Over time, companies have built massive databases of Wi-Fi routers and their locations. So when your phone sees a few familiar networks nearby, it recognizes them and instantly knows where it must be. Sometimes faster than GPS, sometimes more accurate, especially indoors. And even that isn't the full picture. Your phone also tracks how you move. An accelerometer detects motion. A gyroscope tracks direction. All of this gets combined. GPS, cell towers, Wi-Fi, motion. Your phone is constantly guessing where you are, then correcting itself again and again, multiple times per second. So that little blue dot isn't simple. It's not just GPS. It's satellites in space, signals traveling at light speed, invisible networks around you, and sensors in your pocket, all working together to answer one question. Where are you? And now you know. Your phone doesn't just know your location, it calculates it every second, which makes you wonder, if it knows exactly where you are, how much does it know about where you're going next?